are named counterclockwise. So there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Circle by the axes into 4 quadrants. How many degrees is each quadrant, do you think? So that 360 degrees is getting split equally into 4. 90. So each quadrant is 90 degrees. To make that full 360 degree circle, right? Now, when we perform rotations, there's 2 different kinds of rotations. There's a clockwise rotation, which moves exactly how a clock moves. Or there's a counterclockwise rotation, which moves the opposite way that a clock moves. Now, let's say I have a point in quadrant 1. And I want to move 90 degrees clockwise. If I'm in quadrant 1 and I want to move 90 degrees clockwise around the origin, do we agree I'd end up in quadrant 4? But if I'm in quadrant 1 and I want to rotate 90 degrees counterclockwise, wouldn't I end up in quadrant 2? No matter where I am, clockwise or counterclockwise, if it's 180, do we agree we'd end up in quadrant 3 if we're starting in quadrant 1? Okay, let's say I'm in quadrant 3 and I want to rotate 90 degrees clockwise. Where would that bring me? 90 degrees clockwise. No, clockwise, right? Wouldn't we be in quadrant 2? If I'm in quadrant 3 and I want to rotate 270 degrees clockwise, wouldn't that bring me to quadrant 4? Now, let's say I'm in quadrant 3, but I want to rotate 90 degrees counterclockwise. Where would that bring me? Quadrant 4. Right. So that's something we're going to need to know about which quadrant would it bring us into, depending on the amount we're rotating. Another thing you need to know, which is a little counterintuitive here, but if I tell you to rotate 90 degrees or 270 or 180, and I do not specify clockwise or counterclockwise, it is implied that it has to be counterclockwise. I know that's counterintuitive because you want to like move the way the clock moves, but no, if it's not specified that it's clockwise, it's immediately counterclockwise. So I'm going to say it one more time. If it's not specified that it's clockwise, how is it moved? Counterclockwise. So with that said, let's take a guess how many degrees this has moved. So the figure to the right, we have our pre-image ABC, and we ended up with A prime, B prime, C prime. And this arrow is showing me the direction we moved in. So we moved in this direction. So if I'm moving in this direction, is that clockwise or counterclockwise? Mishka? Counterclockwise. So, and how many degrees was I rotated? So if I started in quadrant 2, I bypassed quadrant 3, and I ended in quadrant 4. How many degrees do you think that is? So from 90 to quadrant 3, from quadrant 2 to quadrant 3, wouldn't that have been 90 degrees? And then another 90 degrees to get into quadrant 4. So how many degrees total, Olivia? 180. So we have rotated 180 degrees counterclockwise to produce image A prime, B prime, C prime. Okay, so now we are going to perform our own rotations. We are actually going to rotate a bunch. We're going to rotate 180, 90, and 270, and I specified clockwise in each of these. So let's call these coordinates A, B, C. And now the rule for rotating is different depending on the rotation that we're performing. So to rotate 180 degrees, we're going to draw a line from the point that we're rotating to the center of rotation. And the center of rotation in all of these is what? Says 180 degrees around the origin, 90 degrees around the origin, 270 degrees around the origin. So our center of rotation is the origin, which I'm going to call point O. Now, in order to perform 180 degrees, what you're going to do is you're going to draw a line from the point that we're rotating, and we rotate each point separately. We don't try to just rotate everything at once. So we're going to draw a line from the point that we're rotating to the center of rotation, which this time is the origin. And the center of rotation can change. So we're rotating about the origin. Then what you want to do is you want to find the slope of each line. So to find the slope from point A to my center of rotation, I am going up 1, 2, 3, 4. And I am going to the right 1, 2, 3, 4, 5. So if I'm finding the slope of the line AO, do we agree that's going to be my rise over run, which is 4/5? We okay with that? How I found that? Okay, so now in order to rotate 180 degrees, you're going to go to your center of rotation. In this specific problem, what was our center of rotation? The origin. Can that change the center of rotation? Yes. But you go to whatever point the center of rotation is. And now for 180 degrees, you're going to continue that slope. And now this is where a little insight helps us. Now, if I'm in quadrant 1, 2, 3, I'm in quadrant 3 right now, and I'm rotating clockwise. We move how the clock moves. So if I'm in quadrant 3 and 90 degrees clockwise would bring me to quadrant 2, 180 degrees clockwise should bring me back to quadrant 1. Do we agree? So now if I'm rotating and I'm not ending up in quadrant 1, what does that tell you? Something went wrong, right? So now what do? We go to our center of rotation, and now I'm just going to continue the slope. So from point O, I'm going to go up 1, 2, 3, 4 to the left 5. 1, 2, 3, 4, 5. And this is my A prime. Now I'm going to erase all my lines in my slope because that just gets confusing, right? So we erase that. Found my A prime, we're good there. Am I finished with this rotation? No, we're going to do the same process for the other 2 points. What do I mean? What I'm going to do now is I'm going to find the slope from B to O. Now the slope from B to O, I'm going up 1, 2, 3, 4, 5, 6, 7. So I'm going up 7. To the left, 1, 2, 3, 4, 5, 6, 7. So the slope of BO, do we agree, is 7/7? Do not simplify this fraction. Do not simplify the 7/7 down to 1/1 because that's going to really mess us up. We want to create exactly the same number of counting boxes. So now I'm going to go to my center of rotation. Again, my center of rotation this time was the origin, and I'm going to continue that slope. So I'm going to go up 7 to the right 7, and that's going to be my B prime. And now I have to do this whole process one more time. So now I'm finding from C to O. And from C to O, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. So I'm going up 8. and to the right, 1, 2, 3. So my slope of CO is 8/3, which is my rise over my run. So now I go to the center of rotation, and I'm going to continue my slope. So I'm going to go up, what was it, 8? Up 8, to the right 3. And there's my C prime. And then once we have all of our new coordinates, we connect them in the same order they were connected before. And that is my rotated image, 180 degrees. So this is 180 degrees. CW means clockwise. Jordan. Yeah, so it's exactly what I'm doing. I'm just going super slow. It's like you guys could have just probably figured it out by looking. Yeah. Okay, but now that was 180 degrees clockwise. In order to perform 180 degrees clockwise, you find the slope and you continue the slope. But now in order to do either a 90 degrees or a 270 degrees, you're not going to continue the slope. So for 90 degrees or 270 degrees rotation, use the perpendicular slope. What does that mean? That means if the slope of AO was 4/5, the perpendicular slope will be, who remembers? So if my line AO has a slope of 4/5, a line perpendicular to that slope would have to be what? Jed? The opposite reciprocal. So the line perpendicular to that slope would be the slope of -5/4. In parentheses, I'm going to say opposite reciprocal. So now I have to figure out which quadrant I'm going to end up in. So the first part A, we did that. We did 180 degrees. Part B, we want to perform a 90-degree rotation clockwise. So remember, we're moving how the clock moves. So if my ABC is in quadrant 3 and I want to move clockwise, which quadrant am I going to end up in for a 90 degrees clockwise rotation? Let's label our quadrants again. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if I'm starting out in quadrant 3 and I need a 90 degrees clockwise rotation, which quadrant do I end up in? 2. Perfect. So now I'm going to use my perpendicular slope. So from A to O, my slope was 4/5. The perpendicular slope of that was -5/4. So start at your center of rotation. So I'm going to start at O. And now this time, I know I have to end up in quadrant 2, and I know my slope is -4/5. So, oh, sorry, not 4/5. What was it? -5/4. So that means I have to go up 5, but now in order to end up in quadrant 2, don't I have to go to the right 4? I'm sorry, left 4? And I'm going to call this A double prime since I already used A prime. So we went, oh, I went up 6, didn't I? We want to go up 5 to the right, to the left 4. There we go. Okay, so now the slope of BO was, what was it? 7/7? So then what is the perpendicular slope of 7 over 7? Jordan? Oh, we don't simplify. Negative 7 over 7, right? Opposite reciprocal. So now I go back to my center of rotation. And now I know I have to end up in quadrant 2. In order to end up in quadrant 2, I'm going to go up 7, but not to the right 7. I have to go left 7. And that's my B double prime. Last one for the 90-degree rotation. My slope for CO is 8 over 3. Can somebody tell me what is the perpendicular slope of 8 over 3? Patrice? Negative 3 over 8. So now we start at our center of rotation. And I'm going to go up 3. So we're negative 3 over 8 to the left 8. And there's my C double prime. And then we connect the points to create our image. One more rotation we have to do. So in part A, I said rotate 180 degrees clockwise. In part B, I said rotate 90 degrees clockwise. Now we need to go back to our original pre-image, ABC, and now I want to rotate 270 degrees clockwise. So if I'm starting in quadrant 3, 90 degrees would bring me to quadrant 2. 180 would bring me to quadrant 1. What did 270 bring me to quadrant 4? So I know my image has to end up in quadrant 4. If I'm doing something where my image is not ending up in quadrant 4, I did something wrong. And again, we're going to use the perpendicular slope. So for 90 and 270, we use the perpendicular slope. For 180, we use the same slope. So we already have our perpendicular slopes. So the perpendicular slope of AO was negative 5 over 4. And to get to 90 degrees, we went up 5, left 4 to get to quadrant 2. But now in order to get to quadrant 4, I'm not going to go up 5, left 4. I'm going to go down 5 to the right 4. So one of them is still negative. And there is my A triple prime at this point because we've already done 1 and 2. So there is my A triple prime, 3 slashes. Now for BO, the slope of the perpendicular is negative 7 over 7. So now for BO, for my rotation of point B, I'm going to go down 7 to the right 7 to end up in quadrant 4. And that's my B triple prime. Now for C triple prime, the slope of the perpendicular was negative 3 over 8. So we're going to go down 3 to the right 8. And then we connect. Any questions for me? Okay, so now we're just going to practice this, rotations. Not on full triangles, we'll just practice some points. But now the center of rotation is not the origin for this next one. The center of rotation is the point 2, 1. So it says rotate the point negative 2, 3. So negative 2. Is yours blurry too? I don't like that. All right, there's my point A, which is the point -2, 3. And we're going to rotate it 90 degrees CW. What does CW mean? Charles? Clockwise. So we're going 90 degrees clockwise about the point 2, 1. So 1, 2, 1. This is my point. Let's call this P. And this is my center of rotation. So I'm rotating around that point. And if I'm going 90 degrees clockwise, remember we have 5 moves. And I'm starting in quadrant 2. If I'm moving clockwise, do we agree we should end up in quadrant 1? All right, now clockwise, do we use the same slope or I'm sorry, 90 degrees. Do we use the same slope or the perpendicular slope? Jed? Perpendicular slope. So what we're going to do is find the slope from A to P. So from A to P, we are down 1, 2, to the left 1, 2, 3, 4. To the right 4. So our slope of AP is -2/4. So the slope of the perpendicular is going to be what? So the slope of A to P is -2/4. So the perpendicular slope has to be opposite reciprocal. What's the opposite reciprocal of -2/4, Charles? Not negative, because it's already a negative. So the opposite of a negative is a positive. So it's going to be +4/2. So now I start at my center of rotation. My center of rotation is P. So that means I'm going to go up 4, 1, 2, 3, 4 to the right 2. And there is my A prime. Okay, I want you guys to try 3 and 4 by yourself, and then we'll go over it. Now, remember, in both 3 and 4, I don't specify what way I want you to rotate. I don't specify clockwise or counterclockwise. So if I don't specify clockwise or counterclockwise, what does it have to be? Anishka? Counterclockwise. So if I don't specify clockwise or counterclockwise, it has to be counterclockwise. So you guys are doing 3 and 4 on your own, and then we'll go over it. Yes. Yes. Okay, let's do this. So now we're taking the 0.33, which is the point C, and I'm rotating it around point R, which is 1, 1. So this R is my center of rotation, and I'm going 180 degrees counterclockwise. So if I'm going 180 degrees counterclockwise, this would be 90, this would be 180. So I should end up close to, wait, counterclockwise. Oh, that's clockwise, sorry. Counterclockwise, this is 90. This is, well, it's still the same. This is 180. So I should end up close to quadrant 3. So let's see what happens. To get from C to R, I'm going down to the left 2. So now I'm going, if the slope of CR is down to left 2, for 180 degrees rotation, you just continue that slope. So now I'm going to go down to, oops, that wasn't down to left 2. So that brings me right here to my C prime. And so, oops. So the point for my C prime, so you guys, if you can't see, is the point -1, -1. How many people got that? C prime, -1, -1. Uh-oh. Only 4 people? What happened? Oh, okay. You guys are just not participating with me? Okay. So now we're rotating the point 1, 1 right here. And we're rotating it 90 degrees around the origin. Again, I didn't specify clockwise or counterclockwise, so it has to be counterclockwise. So if I start off in quadrant 1 and I'm going counterclockwise, do we all agree I should end up in quadrant 2? All right, so now to get from my point to the center of rotation, I'm going down 1, left 1. So now I'm just going to continue. Oh, sorry, not continuing that slope. So my slope is down 1, left 1, which is just 1 over 1. So the slope of the perpendicular will be -1 over 1. So what does that mean? I'm going to go up 1, left 1. So let's say this is A. This will be A prime. So A prime should be the point -1, 1. How many people got that? Great. All right, so now we're going to put this all together. We're going to put a rotation paired with a reflection. So they're saying, take my triangle ABC. First, perform a 270 degrees clockwise rotation about the point 21. So if I'm looking at the point 21, do we agree that's point A? So I'm rotating it about point A. And then after we do that, we're going to reflect it over the x-axis. So 270 degrees clockwise. So this is quadrant 1. Quadrant 2, quadrant 3, and quadrant 4. If I'm going 270 degrees clockwise, starting in quadrant 1, if we're going clockwise, quadrant 4 would be 90. Quadrant 3 would be 180. Wouldn't quadrant 2 be 270? So we know we're going to end up in quadrant 2. What's up?
I have a question.
What's up? You know she teaches geometry. You could have asked her. What's your question?
Do you ever mention copyright like kill you?
Jake, you're killing my throat. I didn't even ask the teacher in there.
But like, it's like one of those.
Oh, the ratio of corresponding sides. FBI triangle. It's more about the ratio of the area. So I'm not asking for this, I'm asking for the ratio of the areas. Bye. Okay, so see, he killed my flow, guys. I don't even remember what I was saying. Huh?
Say killed your throat. Or just
Flow.
um,
Like I was teaching flow. Guys, where did I end off?
the end of the lesson.
No, we still have a whole nother part. Okay, so which quadrant did we say we were going to end up in? Quadrant 2. So now we are doing a 270-degree rotation. So are we going to use the slope or the perpendicular slope? 270. Slope or perpendicular slope? Perpendicular slope. What do we use the normal slope for? 180. All right, so now we're going to find, well, A to A is just A, right? It maps to itself. So A is not going to move. So now we're going to go from A to B. The center of rotation is the point A. So from B to A, I'm going left 1, 2, 3, and I'm going down 1, 2, 3, 4, 5. So from B to A, I'm -5 over -3. Do we agree that's just a 5/3? The slope of BA. So what's the slope of the perpendicular? What's the slope of the perpendicular? Jordan? Over +5. Guys, you're just looking at the total sign. So the sign of the original is a positive, so the sign of the perpendicular will be negative. If the sign of the perpendicular is negative, then if the sign of the original is negative, the sign of the perpendicular will be positive. So you're just changing the overall sign and then taking the reciprocal. So now I'm going to go to my center of rotation, and I'm going to go up 3, 1, 2, 3. And to the left 5. 1, 2, 3, 4, 5. And that's how we end up in quadrant 2. So that's going to be my B prime. So A got mapped right onto itself. B got mapped to B prime. Now from C, I'm going horizontal 1, 2, 3 to the left. Well, what's the perpendicular to a horizontal slope? Perpendicular to a horizontal, it has to be Eli? Vertical. So if I went to the left 3, I'm going to go up 3 this time. +3. 1, 2, 3. So there is my C prime. Oh, I went too far up. I went up 4. Erase. And now we connect. All right, and there is my image after a 270-degree rotation about point A. But this is not where we end the problem. After we do the rotation of 270 degrees, what does it want me to do now? Reflect over the x-axis. Well, reflecting over the x-axis is a simple just counting, to be honest, when we reflect. So my point A is 1 unit above the x-axis. So to create that mirror image on the other side, I'm going 1 unit below, and I'm going to call this A double prime. For point B, I'm 1, 2, 3, 4 units above. So I keep the same x coordinate, but now I'm going to go 1, 2, 3, 4 units below. So there's my B double prime. And for C, we are 1, 2, 3, 4. Create that mirror image on the other side. 1, 2, 3, 4. And so now my double primes represent the image of a 270-degree rotation and then a reflection over the x-axis. Okay, the last thing we need to talk about today is dilations. Okay, so for dilations, we actually did dilations. We performed dilations when we were doing similar figures. And when we performed the dilation when we were using similar figures, the center of dilation was always the origin. And so when it's at the origin, it's a lot easier. All you're going to do is take your scale factor and you multiply each coordinate of your pre-image by that scale factor, and that gave you the new image. And we remember if the scale factor was greater than 1, was our pre-image going to get bigger or was it going to get smaller after the scale factor? Bigger, right? If it's bigger than 1, it's going to get bigger. So the figure increases in size. If the scale factor is less than 1, what do you think is going to happen? It shrinks. So it's going to reduce in size. Again, if my center of dilation is the origin, all you do is take that scale factor and you multiply each coordinate by that scale factor to get your new coordinates. But the center of dilation is not always the origin. Sometimes it's just a random point. So what do we do when it's just a random point? What you're going to do is, let's look at this one. Dilate the triangle PON with center P by a scale factor of 3. So now my center of dilation is not the origin, it's the point P. And now if I want to dilate by a scale factor of 3, should this triangle get bigger, Jordan, or should it get smaller?
It should get big.
Yes. Good. So now we're going to get 3 times bigger, right? And the way you're going to do this when the center of dilation is not the origin is you're going to find the slope. Everything comes back to slope. We're going to find the slope from the center of dilation to each point. So here, the slope from point P to point O is up 1, to the right 1, 2, 3. Now, that slope counts as 1. If we're scaling it by 3, we're going to do that slope 2 more times for a total of 3 from the center of dilation to the point. So from P to O, I'm going up 1 to the right 3. So that's 1. Then we're going to go up 1 to the right 3 again. That's 2. Then we're going to go up 1 to the right 3 again. That is 3. So there is my my O prime. How come I don't have a P prime? Anybody know how come I don't have a P prime written down, Jordan? That is the center of dilation. So to get from P to P prime, aren't I just staying where I am, right? So it's not moving because that is the center of dilation. And then what you do is you connect, well, let's just get the other points first, and then I'll tell you what we're going to do from there. So now I'm going to go from my center of dilation, P, to N. So to get from P to N, I'm going down 1, 2, 3, 4. So we're going -4, and then to the right 1, 2, oh, sorry, not down 4, down 3. And then to the right 1, 2, 3, 4. So now remember, my scale factor is 3. So that means I need 3 slopes in total from the center of dilation. So now that counts as 1. How many more do I need? 2 to make a total of 3. So now I'm going to continue that slope down 3 to the right 4. So that's my second time. We're going to do it one more time. 1, 2, 3 to the right 4. And there's my end prime. I'm going to erase all my little markings. And now we're going to connect all my new image points. So now my new image points will be O to N. And didn't the P prime just get mapped right to P since that was the center of dilation? So we still connect P to the other ones to create my triangle triple the size. Okay. So now I'm dilating by a scale factor of 1/2. So are we getting bigger or are we getting smaller? Patrice? Smaller. So this is a little bit different. So now my center of dilation is the point -2, 1. I'm going to call this point, let's call it point P. And then I'm going to name this triangle A, B, C. Now to get from P to A, I'm going up 1, to the left 1, 2, 3. Do we agree? Okay, but now I'm not making this bigger by 2 or 3 or 4 times. I'm making this smaller by 1/2. So what you actually want to do is you want to take, so this is my rise over my run. So you want to take 1/2 of your rise, and that's going to be -1/2, right? And then you want to take 1/2 of your run, which is going to be 1.5 or 3/2, right? So now what that means, what I'm going to do is now I'm going to go up 1/2, or sorry, I'm going to go, well, I guess it doesn't really matter, but from A or P, but I'm going to go up 1/2 and then left 1.5. So up 1/2, oops, still on eraser. So I'm going to go up 1/2 and then left 1.5. Which is right about here. And there's my A prime. And now we're going to do that for the other 2 points as well. Let's do pink. Okay, so now from B to P, I'm going to go from P to B. It doesn't matter either way you look at it. I'm going up 1, to the right 1, 2, 3, 4. So we're +1, +4, which is my rise over my run. Half is just sort of in the negative. So now I'm going to take half of my rise, which is a half, and then half of my run is 2. So what does that mean? That means in the same direction I'm moving from P to B, I'm only going to go up a half, but then I'm going to run positive 2. So there is my B prime. And now we're going to do this one more time for point C. So for points from P to C, I'm going down 1, 2, 3, 4. So I'm going down 4 to the right, 1, 2, 3, 4, 5, 6. So my slope of P to C is negative 4 over 6, which is my rise over my run. So then I'm going to take half of that, which is going to be negative 2 over 3. So what does that mean? I'm going to go down 2 to the right 3. And there's my C prime. And now I connect my points, my new primes, and it looks something like that, creating half the size. Yes. Yep. All right, the last one. Let's make this center negative 3, 0. So we know where the X and Y intercepts cross is the origin at 0, 0. So if I'm going negative 3, 0, 1, 2, 3, that's right here. And this is my center of dilation. Now, are we creating a bigger image or a smaller image if we're dilating by a scale factor of 4? Charles? Bigger. So what we want to do, now this is the first time we're making it bigger when the dilation is not one of the points on it. But it's going to be the same process. To get from our, let's call this center of dilation D. So now to get from D to point A, we're going to go right 1, up 2. Do we agree? To get from D to A, I'm going to go up 1, right 2. Now I want this to be by a scale factor of 4. That first one counts as 1. So that first one to get to my point from the center of dilation counts as 1, which means I need how many more slopes to make a total of 4? 3 more slopes. So I'm going to keep going from A. I'm going to go, what is it? Left 1, up 2, or up to left 1. It doesn't matter. Up to left 1. Up to left 1, up to left 1. So that's 1, 2, 3, 1 more, right? And there's my A prime. There we go. To make it all look the same. Okay, so that was 4 total. So now that's our A prime. For B prime, I'm going to erase all my little slope marks. For B prime, again, you start at your center of dilation. You count your slopes to the point. So I'm just going up 1, 2, 3, 4. Do we agree from our center of dilation point D to B, I'm just going up 4. I'm not going left or right at all. So now that counts as 1. How many more do I need for a scale factor of 4? 3 more. So we're going to go, how many was it? 5? Okay, 1, 2, 3, 4, 5. That's our second one. 1, 2, 3, 4, 5. That's our third one. 1, 2, 3, 4, 5. Was that 4 in total? Yeah? Okay. So there's my B prime. And now for C prime, from D to C, I'm going up 2 to the right 1. So now we're going to do it 3 more times. Up 2 to the right 1. Up 2 to the right 1. And then one more, up 2 to the right 1. Did I go up 3 for one of them? Thank you. When I'm staring at my screen, it's so blurry. Is that better, Jordan? Okay, thanks. And now we connect. And there is our new image. So we are done for today.